So let's solve some quadratics that don't have a b term, have a perfect square somewhere in the problem. When that's the case, you can pretty much just treat it like solving an equation. That means get this y squared or quantity squared by itself. So I'm going to get everything that's not a y squared on the other side. Subtract 4, subtract 4. 5y squared equals negative 40. And then don't take the square root yet. First, divide out this 5. And now I have y squared equals negative 8. Your last step should be take the square root of both sides. So then I take the square root of both sides, I get y equals plus or minus 8 is 2 times 2 times 2, and there's a negative 1 in there. So when I do the square root, I bring out a 2, and the square root of negative 1 is I, so 2i comes out, and underneath you still have a 2. So plus or minus 2i radical 2. Make sure you have plus or minus there. You're going to lose points if you don't. The second one, you got to get this quantity squared. It's kind of like a variable, but it's a quantity. I'm going to divide by 3. And now I have this quantity, p plus 1 squared equals, and 81 divided by 3 is 27. Now I can square root both sides, and I get p plus 1 equals plus or minus. 27 is 3 to the third, so this will be 3 radical 3. And then when you subtract 1 on both sides, you have negative 1 plus or minus 3 radical 3. Don't put your answer as a decimal. I want exact answers. To simplify the square root of 98, you could break this down. That's 49 times 2, and that's 7 times 7 times 2. So there's a 49 in there. I'm going to bring that guy out. That's 7. The square root of negative 1 is I, radical 2. And then to simplify this, you square it at the top. The square root of 8 over the square root of 25, that's 5. The square root of 8 is 2 times 2 times 2, so 2 radical 2 over 5. That's it. There's no square roots on the bottom. So we're done.